All right, it's Mr. Pouts here. Just trying to help you out if maybe you missed class or you want to refresh yourself on the difference between square roots and especially cube roots, which was something new for us here in this unit. So I first want to start us off by looking at squaring a number versus finding the square root of a number. All right, so we have, if you're squaring a number, that's just having the exponent of 2 here. All right, so you notice they all have an exponent of 2. All of them. That just means you're squaring it. All right, and if you want to picture a square, to find the area of the square, well, we know squares have the same side lengths for all the way around. So let's say this is 2 by 2. It's a perfect square. To find the area, you just multiply length times width, which would be 2 times 2, or 2 squared. And we know that is equal to 4. All right, so 5 squared is the same thing. We're just saying 5 times itself twice, which is equal to 25. And if it helps you to picture, since it's called squaring the number 5, you can picture a square again. This one is 5 by 5, and you're finding the area, which is 5 times 5, or 25. Now, lastly, 11 squared would be 11 times 11, which is equal to 121. And you can also picture that square again, 11 by 11 square. You get 121 area inside. All right, so let's switch gears here. Something that's very similar, but it's actually kind of the opposite, are called square roots. Not squares, square roots. So in this case, square roots are actually the opposite. If you notice, we ended up with a 4 answer here, but now we're going to take the square root of 4. So we're going to go backwards. The square root says what number squared equals the number in the radical, which is actually the radicand. And our radicand in this case is 4. Our radicand down here would be 25. Our radicand down here would be 121. Don't be fooled by the terminology. All it's saying is you need to find the number that, if you square it or you multiply by itself, would get you to 4. So in that, of course, you can think, is it 1 times 1? If 1 times itself, nope, that'll be 1. 2 times 2 equals 4, so the answer is 2. And if you're ever asked to show why, it's because 2 times 2 gets you to 4. Or you could say 2 squared equals 4. That's why our answer for that one is equal to 2. Alright, so hopefully this is coming back to you now. The next one that we're going to do is square root of 25. What number times itself gets you to 25? And that, of course, is 5. Because 5 times 5 equals 25. Or if you want to say 5 squared equals 25. That's why 5 is the answer. That's why 5 is the square root of 25. Now, the last one might not be as common, but it'll be the one that's right above the square root of 100. The square root of 121 is actually equal to 11. Because over here we see that 11 squared is equal to 121. Okay, so again, square roots, just figure out what number times itself gets you to the number underneath the square root symbol. All right, so what number times itself would get you to 121? What number times itself would get you to 25? What number times itself would get you to 4? All right, now we're going to shift gears and we're going to look at cubes versus cube roots. Okay, so we're going to say over here, these are cube roots. And we can label up here, we'll say those are cubes. Now, These are both very similar to squares and square roots, only just a little change. If you notice, for cubes, cubing a number, it's called cubing a number because the exponent for this is always equal to 3. And if you know a cube, instead of being a square, it has 3 dimensions instead of 2. So if you cube a number, that means it always has an exponent of 3, which tells you to multiply that number by itself 3 times. And in our first situation, we have 3 times 3 times 3, and that is equal to 27. So 3 times 3 is 9, times 3 is 27. For this one, it would be 7 times itself 3 times, which is actually equal to 343. All right, 10 cubed is 10 times 10 times 10, and that equals 1,000. And then lastly, 5 cubed would be 5 times itself 3 times, and that is going to get you to 125, because 5 times 5 is 25, and then times 5 again gets you to 125. All right, so what does that have to do with what we call cube roots? Kind of like squares and square roots, now we're going to do cube and cube roots. The only thing that's different between a square root and a cube root is this little guy right there. It's saying it's a 3. That means it's a cube root. All right, if you notice, that's on all of them. Now for a square root, you want to try to find, since it's a square is two-dimensional, you want to find a number times itself. So one number multiplied by itself. So two numbers there that would multiply to get to our radicand. In this case with cube roots, since we're talking cubes and three-dimensional, we want to find a number that multiplied 3 times would get you to what's underneath the square root sign. So what number cubed equals the radicand? And again, the radicand is just a number underneath the root symbol. So we have 27, 343, 1,000, 125. So let's look at the first example. We have to figure out what number cubed equals 27. So a number that multiplies by itself and then multiplies by itself again equals to 27. Well, if you look over here, we already figured that out actually. 3 times itself 3 times would get you to 27. So our answer is 3. Because 3 times 3 times 3 equals 27. Now this one down here is going to be kind of nice again because we did the work over here. What times what times what, if it's the same number, gets you to 343, and that is 7. If you type it into your calculator or do the math, 7 times 7 is 49, and then 49 times 7 again gets you to that 343. All right? So it's because 7 times 7 times 7, remember there's 3 times this time, equals 343, which is what's underneath the radicand. Alright, you might be able to guess from our work over here that what times itself 3 times gets you to 1,000 is 10. Alright, and then lastly, this one's going to be 5, because 5 times 5 times 5 equals 125. Okay, so I did have a couple challenge problems that I want you to think about. The first one is cube root of 8, then we have the cube root of 729, cube root of 1/8, so we have a fraction in there, and then the fourth root, I wanted you to think about that one, of 81. So take a second to pause this, and you can try those 4 on your own. Now, if you unpause it, we're going to use purple here. So a number times itself 3 times, getting to 8. Let's think small, because it's going to have to be smaller than 8. Maybe 3? Nope, we said 3 times 3 times 3 is up there. It gets you to 27. So let's try smaller. 2 times 2 times 2 equals 8. Good. 2 times 2 is 4, times 2 is 8. So our answer is 2. Alright, this one, let's just take a guess. Maybe 8 times 8 times 8. Let's pull out our calculator here and go to 8. times 8 times 8. 512, not quite. Let's try it over. We'll go 9 times 9 times 9, and you get 727. So 9 is our answer. Lucky number 9. 9 times 9 times 9 equals 27. Alright, this one down here is kind of tricky. You have to think something times itself equals 1/8. If you want to put it into a decimal, you can, but you don't have to. If you think of multiplying fractions, you just multiply all the way across. So I'm going to give you a hint that the top is going to have to be 1, because if you multiply all the way across, 1 times 1 times 1 is equal to 1, which will be your top. You want the bottom to equal 8, so we already figured out 2 times 2 times 2 equals 8, and so that works out. It's equal to 1/8, so our answer here is 1/2. Multiplied by itself 3 times gets you to 1/8. And then lastly, the fourth root is a number that multiplies by itself 4 times instead of 3 to equal 81. And, well, if you know that 9 times 9 equals 81, that's a square root. Then you could take the square root of 9, and that would be 3. So, let's see. 3 times 3 is 9, times 3 is 27, times 3 equals 81, and that's what we're trying to get to. So our answer for this one is 3. Alright, so that is our quick check of cube roots. If you want to help you remember the difference between square roots and cube roots, here's a great example. Just a great little cheat sheet that you can leave on your screen. What number times itself gets you to the given number? Just the number times itself. And this one is what number times itself gets you to the given number. Alright, so that is our review of cube roots. I hope you enjoyed it, and I hope you do well with it.